Welcome everyone to Algebra 1, section 10.3, dividing rational expressions. So we worked on multiplying last class. So dividing, whenever you're dividing fractions, we just multiply by the reciprocal. So we're going to take one extra step from last lesson, and we're just going to have to reciprocate it first. So let's start off with a more basic one with just numbers, no variables. So we start off 2 over 3 stays the same, divide towards multiplication, and the second fraction gets reciprocated and becomes 5 over 2. Once again, we look to cross-multiply, or cross-simplify, I should say, not multiply. Cross-simplify, the 2 and the 2 become 1 and 1, and we're left with 5 over 3 as an answer. We'll carry this same exact process into the more complicated problems with rational expressions. Meaning this first parenthesis is going to say, the first fraction, I misspoke again, is going to be exactly the same. The second fraction just reciprocates. Everything on the bottom goes to the top. Everything on the top is on the bottom. And now we look to simplify just like we did before. A squared and A squared both reduce to 1. B cubed becomes B squared, and B just becomes 1. C becomes 1, and C cubed becomes C squared. M squared becomes 1, and M cubed becomes M. Y squared and Y squared just reduce to 1 each. So as we kind of sort through what we have left, we have a B squared and an M on the top with a bunch of 1s. So we're left with B squared M. Let me make that more of a B. Third time's the charm. On the bottom, we're only left with a C squared and a bunch of 1s, meaning our answer is B squared M over C squared. Example 3, we're going to start off once again. The left fraction is going to stay exactly identical, 2A over A plus 3. The right fraction will become A plus 3 over 2A plus 14. You might notice, like we had last class, we can simplify by factoring first and making this a 2 times A plus 7. Well, all of a sudden now, this 2 and this 2 can reduce, and then the A plus 3's could still reduce. So on the top, we're left with A. On the bottom, we're left with A plus 7. And that's where we have to end that problem because we can't reduce those A's since 1's a part of the addition, not being multiplied to anything. Example 4, hard to believe we're already halfway through the examples, although these do get a little bit longer now. Left stays the same, x over x plus 2. Second reciprocates, x squared plus 5x plus 6 over x squared. I'm going to make the x to factor out the top right. That's going to give a 6 and a 5, which is going to be positive 3 and 2 in either order. I'm going to go ahead and rewrite into x over x plus 2 times x plus 3, times the fraction of x plus 3 times x plus 2 over x squared. Reducing, x plus 2 and x plus 2 reduce to 1 and 1. X reduces to 1, and x squared just reduces to x, meaning we're now left with x plus 3 on the top and an x on the bottom, and we're done with that problem. Give myself a little barrier here to start number 5. Number 5. I'm going to start just by rewriting the first. Reciprocating the second. 4a squared minus 25 over 8a squared. All right, so top left factors out a 4, and we're left with a squared minus 1. That is going to be a difference of 2 squares for us to note. Bottom left, this one's going to be a little bit messier because we have to factor by grouping and rewrite it. So as we do that, we make the x. I'm going to make the x up here to save myself some room. The top will be negative 10, a times c. The bottom's positive 3. Negative 2 and positive 5 do the trick. For factor by grouping, I'm going to do it, I'm going to make it over here, since I have room over here. I'm going to do 2a squared plus 5a, minus 2a, I'm going to do the negative first, plus 5a minus 5. First 2, last 2. First 2 I can take a 2a out of, and I'm left with a minus 1. Last 2, a positive 5, and a minus 1, meaning it factors into a minus 1 and 2a plus 5. So I can write that here, a minus 1 and 2a plus 5. My top right is the difference of two squares, and it factors into 2a minus 5 and 2a plus 5. And my bottom right one does not factor. So now I still need to factor the top left, which was another difference of two squares, one more time. So that 4 times a squared minus 1 is going to become 4a minus 1, a plus 1. And all the rest of it's already factored. A minus 1 on the bottom left times 2a plus 5, which I forgot a parenthesis the first time I realized. Top right, 2a minus 5 and 2a plus 5. And bottom right is already factored as much as it can be, no factoring, as 8a squared. Now I can simplify all of this. A minus 1 and a minus 1 reduce. 2a plus 5 and 2a plus 5 reduce. 8a squared and the 4, we can do the 4 and the 8 to make that 2. And that's as much as that simplifies, meaning we're left with a plus 1 and 2a minus 5 on the top. On the bottom, we're left with 2a squared. Oh, my apologies. Earlier, when we factor out this GCF as 4, it should have been 4a. Let me go back and fix that. So what that does is a trickle down, and you might have caught this way before and you've been confused this whole time. And if that's you, I'm sorry. So that'd be 4a. So what that does down here is it makes it 4a outside that parenthesis. And so those also reduce. The a reduces to 1. The a squared reduces to a, which makes our final answer all over 2a. And I would encourage us keeping our answer like this, not multiplying the top together, since it will not benefit us. Moving on to our very last example. I'm just going to rewrite the first. X squared plus 6x minus 27 over x squared plus 11x plus 18 times, and reciprocate the second fraction, x squared plus x minus 2 over x minus 3. Ooh, lots of x's we get to make. Top left, negative 27 on the top, positive 6. That's going to be a negative 3, a positive 9. So that top left factors into, I'll just rewrite it again for simplicity's sake, x minus 3 and x plus 9. Bottom left turns into an 18 on the top for the x, 11 on the bottom, making it 9 and 2 or 2 and 9, meaning that factors into x plus 9 and x plus 2 in either order. Top right, negative 2 on the top, positive 1. It's a negative 1 and a positive 2. So that factors into x minus 1 and x plus 2 in either order. And the bottom right just stays x minus 3. Now we simplify what we can. X minus 3 and x minus 3 reduce, x plus 9 and x plus 9 reduce, and x plus 2 and x plus 2 reduce. Meaning after all of that factoring and simplifying, all that we're left with is x minus 1 as our answer. That is section 3, dividing rational expressions.